Okay, so even though I've had to record this 4 different times, because of distractions and the file corrupting and everything else, hello. And today we're going to be talking about geometric sequences because we have to solve this equation right here. Anyways, I'm not reading all of this again. All you need to know is that the first term is 4 and there's 3 different terms and we don't have the common ratio or anything like that. But they all are supposedly supposed to equal 28. And, we have to do all of this. So anyways, without explaining further and losing it again, and hopefully this file doesn't corrupt, so we know that 4 is our given, there we go. 4 is our given term, and obviously we have our A1 term, which is 4, plus our A to a second, and then our A third, I hope that's correct, which is all supposedly supposed to equal 28. Another way you could write this is supposedly 4 plus A times the ratio plus 4 times the ratio squared, which equals 28. And from there, I'd want to divide all of these out by 4, mainly because the only way I know how to do this, besides, I'm not even sure if you can really do it the quadratic way, but we have to simplify and then factor. I'm thinking that's the best way on how to do it. Anyways, so doing all of that will get you 1 plus r squared. R squared equals 7, and then moving this 7 over here and subtracting it by 1 and rearranging the numbers is going to be r squared plus r plus 6 plus 6, not plus 1, equals 0. And from there you can factor, and it is this long equation that I did last time, which I don't really feel like doing now. I can tell you that you do get r plus 3 and r minus 1, and you do have to flip the signs. But anyways, so the common ratio is going to be either r minus 3 or r plus 2. So there's 2 different ways you can do it, at least I think, because I solved it earlier and this is the best conclusion I can come to, because honestly this problem is very difficult. But anyways, so now that we have this, even though I do kind of favor the 2 more just because it is positive and I feel like that will represent the common difference more. So anyways, now that we do that, okay, now that we have factored the quadratic thingamabob, then now we know our nth term is supposed to be 7, and our A1 is 4, and the common ratio, all of that, yada yada yada. Anyways, so now that we know that, we can start setting it up with this formula equation thingamabob that I like to classify as 1 times parentheses r, because we have to have it in its own little spot, and then our nth term, which is supposedly 7, that's going to be 7 minus 1, and that's all you need to go on to the next step. Okay, so you can get rid of all of that now. So then you make this ginormous line, and remember the formula that we used earlier, and then we do 4 because we have to try out both of these. 4 and times -3, and then 7 minus 1, and then you do the same for R2. Well, we do the same for R2, and that is going to be yada 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 and raised to yada yada yada. Okay, and that is supposedly what it's supposed to look like. And then we have 4 times our -3. This does not change, fortunately for us, but it is going to be raised to the 6th power, and the same goes for this one. So this one is going to be to our 6th power, and then from there you work on the actual problem. So that is going to give us 729. -3 to the 6th power is going to give us 729, and and then 4, and then 2 to the 6th power is supposed to give us 64. Okay, and then from there you can go straight into this, which is gonna be we actually have to write our A7th term, because I did not do that up here, but it is important, and in math we like to be right. And let me see, A7 equals, and then from there you just times straight into the 4. Okay, and that is gonna leave you with, again, I repeat for the 4th time, 2,916. Okay, and this is going to be 256. And even though we do favor this one more, I suppose this one is still an option. But yes, that is the speedrun version.